So we're going to teach the Hell-Volhard-Zielinski reaction, which is going to turn this propanoic acid, these are the 3 carbons, the 2 oxygens, the hydrogen that's on the OH of the carboxylic acid, and then this is the hydrogen we're going to be reacting, so it's the only one that's shown, into 2 bromopropanoic acid. So we're going to replace this hydrogen with a bromine. So the first step is going to be to react this PBr3, the phosphorus, these are the 3 bromine atoms, with this alcohol group within the carboxylic acid, and this phosphorus group has a partial positive charge and this oxygen has a partial negative charge. So this phosphorus and its extra lone pair are going to attach to the oxygen, and it's going to kick off one of the bromine atoms. So you're going to get this phosphorus attached to 2 bromines, just like this molecule, which has the oxygen with the plus charge that I've represented by the little piece of blue straw. As you can see, it's attached to the phosphorus ion with 2 bromines. So you have the extra bromine ion, which is going to come attack this carbon and create 5 bonds. So you know what we have to do now? We have to remove this bond, and then this oxygen is going to have a negative charge. So you're going to have this molecule. So then, as with most alkylations, this bond is going to come down and it'll look something like that. And then this, since it's become a good leaving group now, since it has this plus charge and the bromine, is going to be removed. And you're going to be left with this carbon, double bond to the oxygen, with the bromine attached to the... And as a side product, we have this phosphorus molecule that has an OH attached to it instead of the bromine, which it originally had when it was PBr3. So right now we have the ketone form of this acid bromide, but we need to make the enol form. And you might ask yourself, how do I make the enol form? And luckily for you, there's an HBr over here, and you have Br2 gas as well, but that's not important right now. And this HBr, this oxygen is going to take this hydrogen, and this bond's going to break to make a little, there's going to be a plus charge here, and this is going to turn into a bromide ion, just like this intermediate. So now, this bromide ion you made is going to work as a weak base and take this hydrogen, and then this bond is going to break and form a double bond. So then this double bond is going to break, so the electrons will go onto this oxygen, which will remove this plus charge, and then your little bromine that you had is going to make a bond with this hydrogen to form HBr. So that's a catalyst because we just regenerated it. So now you can pat yourself on the back because you made the enol form just like you wanted to. Good job, self. So now that you have the enol form just like you wanted to, one of the 2 lone pairs on this oxygen is going to come down and form a double bond. So now this carbon has 5 bonds, and you don't want that. That's a big no-no. So then you want this double bond to come over on this carbon, and it's going to attack one of the bromine from that Br2 you put in the solution because you're smart and you remember to put it there. And it's going to do this, and then this oxygen is going to have a little plus charge. So you're going to get this intermediate and a bromide ion. So now the bromide atom you made is going to come over and take this hydrogen, which will remove this plus charge, remove the minus charge from the bromine, and make HBr, which, if without the presence of water and with a bad solvent, will just evaporate as a gas. So now you're going to add your old pile of water, and water has these 2 lone pairs in the oxygen, which are going to come attack this carbon and move this bond up here, so this oxygen is going to have a negative charge, and it'll look just like this. And since your little buddy bromine is such a good leaving group, this electron will come down, make a double bond, and this will leave, which will leave you with this intermediate. So now, another molecule of your old pal water is going to use one of its 2 lone pairs to take one of the hydrogens and make an old classic hydronium and leave you with, oh look, 2 bromopropanoic acid, just like you wanted. Way to go!